Okay, now I'm going to talk about parallel vectors. Okay, so let's move on with parallel vectors. Okay, what do we know about parallel vectors? Now the first thing is what we need to realize: a vector can be parallel to another vector, like this. And if you have, let's say this is the vector A, and this one is vector 3A. Why both is A? Because they're in the same direction. For vectors to be parallel, they've got to be in the same direction. But it doesn't mean that parallel vectors can be equal, although they can be equal. But a lot of times you will come across the fact that parallel vectors are parallel, but they are not equal. Like in this case, this one is A and this one is 3A. Alright, so it could be that the length would be different. Alright, so they may not be, they may differ by magnitude, okay? They may differ by magnitude. So if vectors differ by magnitudes, okay, then, but they are in the same directions, then they are parallel. So we can take an example to explain this to you. Alright, and let's say, for example, if I give you the vector OA, and suppose vector OA is equal to A, vector OB is equal to vector B, and let's say vector OC is equal to half vector vector OA, and then OD is equal to half vector OB. Now, and I tell you to prove, okay, that vector AB is parallel to vector CD. Okay, how are we going to do this? Alright, again what we are going to do, we're going to draw a diagram. Let's say that this is the vector OA and this is your vector OB. And let's say C is somewhere halfway and D somewhere halfway. Because we are told that this is half OA, half OB. OD is half OB and OA is half, OC is half OA. Okay. Now, we can find the vector AB. We know that vector AB is equal to vector AO plus vector OB by geometry of vectors, which is then minus A plus B. That we already explained. So B minus A is not very difficult. It's not at all a trouble to find the vector AB. That's okay. We need to prove that this vector AB is parallel to the vector CD. Now, we can prove that they are in the same direction. If once they are in the same direction, then they are parallel vectors. And how are we going to prove that they are in the same direction? Is simply by finding the vector CD now, because we need CD. AB has been found already. So let's find the vector CD. I just draw a line here, so make it easy for you to spot. And now I want to find the vector CD. So this vector here. Draw a line here. So this is vector CD. So vector CD is CO plus OD. CO plus OD. Now I know that OC is half OA, but CO is the opposite. So minus half OA, which is vector A. Then plus OD, and OD has been given as half OB, which is half vector B. So that means it is half vector B minus half vector A. And therefore I have half into B minus A. So this is my vector CD. What is common with these two vectors? Let us look carefully here. Vector AB is B minus A. Vector CD is also B minus A, except for one thing, that the vector AB has a magnitude of 1 and the vector CD has a magnitude of half, which is pertaining to this. Alright, a vector can be in the same direction, but they can differ by magnitude. Here they differ by magnitude of 1.5. So we're going to say, since vector AB and vector CD are in the same direction but differ. Yes, since the vector AB and CD are in the same direction but differ by magnitude of half, therefore AB is parallel to CD, and that's it. Hi, in this video we're going to talk again, we're going to continue about parallel vectors. Alright, so like I explained before, we can have two vectors that are parallel. So therefore, let's take a look at, say for example, if I give you something, this is about vectors and we're talking about parallel vectors. I give you that the vector OA is equal to, let's say, 3, 4 is parallel to vector, let's say, xy, which is equal to h and to h plus 1. Alright, and I tell you to find h. Remember, h is a scalar. Hang on a second. Let's wipe this out. Now this is the information that we have, and we want to find h given that the condition is such that these two vectors are parallel. Now when vectors are parallel, I did explain to you before that if you take a vector like this, another one like this, they will differ by magnitude. Say for example, this is some vector A, this could be equal to k times A. So we're going to use this concept and apply this concept over here to help us to find the value of h. So how we do this? So we're going to say, bring k into perspective. Okay, so we're going to say vector OA, because the vector OA is parallel to the vector xy, we can say k times the vector xy. And therefore, I have OA, which is 3, 4, is equal to k times xy, and xy is h, and then h plus 1. So what we're saying is that h times k is kh, and that is equal to 3, and I have k times h plus 1, and that is equal to 4. Right, now from here, what can we do? If we take the second equation, this is your first equation, we can solve these two equations simultaneously. Okay, by distributing this, we're going to get kh, okay, plus k is equal to 4. And over here, you've got kh is equal to 3. You can clearly see that this kh is equal to 3 can be substituted here. Now we know that kh is equal to 3, so therefore I've got 3 plus k is equal to 4. And that means k is equal to 4 minus 3, and so k is equal to 1. Now if k is equal to 1, it's very easy for us to find h. We can either use the first equation, or you can use the second one. This one seems a lot easier, so I'm going to use the first equation, k times h is equal to 3. That means k times h, k is 1, 1 times h is equal to 3, and therefore h is equal to 3. This is how we go about to find the value of a constant if the vectors are parallel. But here the constant is basically k. K is the scalar, because k is the number that is multiplied by the other number.